Hi, welcome to Flemdog Tutorials. Today we're going to be predicting products, which is a great challenge, has a number of steps that I think we can figure out together. Let's just start out with this one right here, the aluminum reaction with copper chloride. So how are we going to do this? First, let's write it down. Aluminum reacting with this copper. It looks like we got copper-2 chloride, copper chloride right there. And it makes something, some mysterious thing. So how do we figure that out? Here's how we figure it out. Let me give you a really quick breakdown, get a few colors here. All right, there are 5 types of reactions you want to be able to identify somewhat readily. The first one is called a synthesis reaction. Synthesis. And what happens in a synthesis reaction is you have one thing react with another thing, I'll put a plus here, to produce a combo. They went together. So that's a combination or synthesis reaction. Now these things, I teach high school, so like a lot of high school relationships, you know, it starts out good, but then there's the breakup. So A, B start together, but then they sadly split apart into A plus B. Put that B right over here, like this. And we call that decomposition. When we have one thing that splits into two. I'll just put decomp. Okay, decomposition. The reason decomposition happens, the reason that breakup sadly happened, was we had A, and then I'll put B and C right here. So B and C are together. What happens is that we have a little switcheroo that happens. So A replaces B. They switch. This is called a single replacement reaction. So if A replaced B, that means B's on its own now. And A and B are usually the positive metals here. So we have our B, and now A is with C. Like this. AC. So they switch partners. That's single replacement. Single replacement. Better just stop right there. Single replacement. And the other one, very similar to single replacement, is called double replacement. Okay, double replacement. And what happens with that is you have two things that start together. So you have A and B. And then you have your C and D. And we have a double buddy switch that happens. So A and C, the metals, we could say switch, or you could say the non-metal switch. I like thinking about the metals switching. So they switch, and we have C and B. So C is now first, stuck to B. And A is now stuck to D. Right there. So that's a double replacement reaction. And the very last one, whenever something burns, it's called combustion. I'll just put combust right here. And for that one, you have a carbon compound and a hydrogen. So it's a carbon and hydrogen, and there's some amount of them. We can just abbreviate that X and Y. So some amount of carbons and hydrogens. They react with oxygen that's in the air, and they produce CO2 and H2O. So when you're predicting products, this needs to be either on a toolkit or in your mind, in your heart, but knowing this is really, really helpful. So then you go back to your actual problem that you're given and you say, what does this look like? Well, if I were to sort of summarize this, I would say this looks like A, this metal looks like B, and this looks like C. So who does that connect most to? A, B, and C are stuck together. So this would be a single replacement. So what's going to happen? My B is going to end up by itself. Copper is going to end up by itself. And this is going to switch. A is going to switch with B. So aluminum will now be with the Cl. Okay, so when you do these, one nice thing, it doesn't really come up in this one, but aluminum on the periodic table. So this is, this would be step 1. Step 1 is figure out what are your products. Step 2 is when you have an ionic compound, I'll kind of put this right here. This is step 2, is to figure out what are the numbers that go with each one. So to do that, in this particular problem, we need to know that aluminum right here, this is one that you sort of memorize, but aluminum, gallium, indium, they always become 3+. So this aluminum is always going to be the 3+ ion. And chloride right here is always going to gain 1 electron to become Cl1-. And if you're curious how to do these, get some practice on those, we have some videos on making these ionic compounds, but let me just go quick here. Overall, we need the 3+ to be canceled by the minuses. And since we have 3+, we're going to need 3 minuses. And the way that we show 3 minuses is by putting a 3 right there. And this would be a 1, which you don't actually have to write down. So if I wrote this how it currently stands, we have everything here, and I'll just pretend that that 1's not there, but it's good to know that we have 1 of those. So that was step 2, figuring out your ionic compounds. Step 1, figuring out your products. Step 2, figuring out your ionic compound formula. Your step 3 is to balance. So this is your step 3, balance. So we got some videos on balancing. If you'd like to work on those, just check them out in the playlist, and super helpful. Maybe, I don't know. Hopefully they're helpful. So aluminum, currently we have 1 aluminum on the left side, and our goal is to make this balanced here. So this is like our little fulcrum. Right now we got 1-to-1 aluminum, so that's balanced, that's great. Copper, we have 1-to-1, that's great. Chlorine though, our chlorides, we have 2 on the reactant side and 3 on the product side, and that is not good. So we need to get those equal. And what's the first number 3 and 2 go into? 6. 2 times 3 is 6, and 3 times 2 is 6. So the way that we show that is 2 times 3 is 6, and 3 times 2 is 6. So this is a 2 right there. Okay, but that just messed up the other things we did, but not too bad. This now says I have 3 coppers, as well as having 2 chlorides 3 times. So if I have 3 coppers, over here I have 1 copper, I need to put a 3, so I have 3 coppers on both sides. And aluminum, now I have 2 aluminums, so let's go back over here and get 2 aluminums. That should be it. Let's just double check to make sure we got it. 2 aluminums and 2 aluminums. 3 coppers and 3 coppers. 2 chlorides 3 times, 2 times 3 is 6, and 3 chlorides 2 times, 3 times 2 is 6, and we got it. So our 3 steps for doing that. Step 1, using our 5 types of reactions, predict your products. Step 2, based on the products you predict, find your new ionic compounds. And step 3 is balance. So we balance those out. I hope that helped you. If you have any questions, let me know. I'd love to make your chemistry journey more fun and exciting and manageable. I'll see you soon.
Wonder, oh wonder.